For the recommendation, we can also use some other methods to look at the retrieval quality. What does it mean by retrieval quality? The retrieval quality depends on individual capability to formulate queries with right keywords. So if they are so long words, it will be difficult for us to understand. So we need to have query. Do you know query? So in the database, you will learn about query. So query means we want to extract some keywords, or we want to extract based on the words. We call it the keywords. And one method that is query-based readable, we call it ROQs method. So using the smart system means we would like to have a users to rate whether it is relevant or irrelevant of the retrieved documents. So the system then learns a prototype of relevant or irrelevant documents, and the queries are then automatically extended with additional terms or weight of the relevant documents. So I think it's better to look at the examples. We have a document D plus and D minus. So D plus means the documents that the user like. D plus means the documents that the user like, and D minus means the documents that the user dislike. And we need to calculate the prototype factor for this category. So you can calculate this using some methods like cosine similarity. Okay. So let's say the circle, this circle with white, it is relevant documents, and X, it is non-relevant documents. And we can calculate the centroid. The centroid means the center point. So let's say this has the word, and this also another word, and this is the centroid. This is the document which has the non-relevant keywords, and this is the centroid. So we can calculate the centroid of this one with the centroid of this one. So this is the centroid for the relevant document. This is the centroid for the non-relevant documents. Then we can compute the modified query from the current query. Means that now I have a preference. The current preference. Okay. Now I have the current preference, and I want to check whether my current preference will change according to my queries or not. So it will change or not. And how big is the changes of my current preferences? So in the formula, we have the Q1, Qi plus 1 means the next query. It is the alpha multiplied by the Qi plus the beta multiplied by the amount of D plus or like, and minus by gamma, the amount of the dislike. So alpha, beta, and gamma, it is used to fine-tune the feedback. So alpha is the weight for the original query, beta is the weight for the positive feedback, and the gamma is the weight for the negative feedback. So this is the original query. This is for the positive feedback. This is for the negative feedback. Okay, so this is the plus is the positive and D minus is the dislike. So in many applications, often only positive feedback is used because the positive feedback, it is mentioned that it is more valuable than the negative feedback. So when we have the calculation, okay, let's say now my position is here. This is the Q0. This is the first query, the initial query. And after I know what is the current query, the positive query, and what is the negative query, then it will change to the new query or it is the position of Q1. So the relevant feedback, so after the feedback, the original query is moved toward the cluster of the relevant documents. So if it is the cluster of the relevant document, this is the non-relevant document. So we can check in the position of the coordinate whether it is moved to the relevant document or it is moved to the non-relevant document. And of course, we want to move this to the relevant documents. So let's check with examples. So category recommend intelligent learning, school, and field. So it is a table, okay, or a factor. And the user initial profile is 10100, 10100. So 1 represent the word recommend, intelligent represent the word this one 0, learning this one, school this one, and field this one. So it means the user initial profile, he or she likes the documents related to the word recommend and learning, because one is recommend and one is learning. Okay. Now let's say there is a book. Okay. Book, and this book is the relevant document. We call it DR. The book title is Intelligent System with Recommender System. And this book, when we look through the book, the keywords, okay, the keywords recommend appears 2 times. The keyword intelligent appears 2 times. The keyword learning appears 1 time. The keyword school and field, both of them appear 0. So no keyword school, there is no keyword field. Now I have another book. So DN means the non-relevant document. So the book title is Failure on Learning Recommender System. And this book has also another keyword. The keyword is recommend. There are 2 recommend, 0 intelligent, 1 learning, 0 school, and there are 3 words of fill. Then we can calculate. How to calculate? It means, yeah, I show you the calculation here. For the original query, we have 1 recommend and we have 1 learning. For the relevant document, we have 2 recommend, 2 intelligent, and 1 learning. For the relevant document, we have 2 recommend, 1 learning, and 3 fill. So using this one, we can do the calculation. Okay, so this is the word before. given the information original query, which is Q0, relevant document, which is DR, and non-relevant document, which is DN. So we want to know the new query. We want to know what will be the next query or the Q1. This alpha, beta, and gamma, it is given. Because we want to know what is the next relevant document. Then we give beta high value, which is 1. And the original query is 1. Because we know that the current state is important. But we put the non-relevant document with 0.5. It is lower than 1 because it is maybe less important. Okay. So the next query will be calculated 1, which is from alpha, multiplied by the Q0 plus 1, which is from the beta, multiplied by the relevant document minus by 0.5 multiplied by the DN, which is the non-relevant document. So we can just calculate with the factor, with the factor, with the factor. So we put the Q0 here, and then we put the DR here, and we put the non-relevant document here. We just multiply with the weight, and yeah, we can get this number. If you look at this calculation, you can get this number 2 to 1.5, 0 minus 1.5. So if we have the minus 1.5, in this factor, it is better to maintain to find the positive feedback. Yes, like I mentioned to you before. Whenever we use this one, we want to look only the positive feedback. So if it is negative, usually it refers to something less important, not important. Then we can remove this one and just make it as 0. Then this is the new query. So the new query means whenever you find a new book, or if you want to recommend books to this user, make the word recommender as important and the word intelligent important, and also the word learning as important. So it means this is the updating query. Before doing the calculation, we have the original query only recommend and learning, but now we have the word recommend, intelligent, and learning for the new query, and so on. So we can also create the Q2. We can also create again Q3. We can also create again Q4. And if the time goes by, of course, this will be updated, So this is the Rocio's method. So in the Rocio's method, there are some challenges. First, the number of items rating needed to build reasonable user model. If we look at this, if you look at this one, this is already determined that this book is relevant. This book is non-relevant. But how can we know that this book is relevant and not relevant? Yeah, we need to rely on the rating. If we don't have the rating, then we cannot look at this relevant and non-relevant. That's why we need to have the number of item ratings needed to build reasonable user model. Again, you can automate this one by capturing the user rating implicitly. Implicit means this is implicit rating. You click document. Okay, if you use the document that you may like the document. So if the user clicks on the recommended items, then it is a relevant document. If the user does not click on the recommended item, then it is non-relevant document. Okay, so this is the way to distinguish between relevant and non-relevant. Or sometimes we can use the pseudo-relevant feedback. You know what does it mean? Pseudo-relevance. So pseudo-relevance means something that we predict the feedback, and the prediction result can be used to distinguish whether it is relevant or not. So you can say like this one. Using the rating prediction, okay, after you have the prediction result, then if the rating prediction is higher than, for example, 3.5, okay, this is relevant. So something like that one. So assume that the first n document matches the query best. So let's say if I have 100 books, okay, so I want to recommend only 10 books that are matching with the query. So the set of non-relevant document or D minus is not used until explicit negative feedback exists. So if you look at the pseudo relevance, then if you use the rating prediction, if you look at the person correlation, there might be some negative. You still remember when we use the person correlation, some can be negative. So if it is negative, we can put it as a negative or non-relevant document. The other way, we can use the user interaction required during the retrieval phase. It means when we want to retrieve, we ask the user continuously. So interactive query refinement opens new opportunity for gathering information, but this is highly time consumption. Okay, so because you need to have the user feedback every time. So it helps the user to learn which vocabulary should use to receive the information he needs. Yeah, now it is easy because the keyword is very small. Okay, the keyword is only 5: recommend, intelligent, learning, fail, and school. But in a book or in a movie, the keyword will be so many. It's not easy. So sometimes we need to have the user feedback. We have another way, we call it the probabilistic method. Okay. So just make the probability. So last week we also learned about the naive bias. We use the uh, probability to know what will be the rating. So using this probabilistic method, we can also use it for the content-based recommendation. So the probabilistic method, it is the classical text classification problem. It is long history using the probabilistic methods. The simple approach is we can make two classes. So two classes means whether it is trend or not, it is hot or cold, or it is relevant or not relevant. And we can make a simple Boolean document repetition. Simple Boolean means whether this word appears or not. This word appears or not. If it is one, okay, this word appears. If it is zero, then the word does not appear. Okay. Then if it is one, okay, the word recommender appears. The word intelligent appears. The word learning appears. The word school does not appear. Then, okay, the label is one. Okay, the label one means it is relevant, or maybe it is a trend. The second book, recommender is zero, intelligent is zero, learning is one, school is one, and the label is zero. Okay. So using this data, we can calculate the probability. What is the probability that the X, okay, X means the feature, given the label one, given the label equals to 1. It means I want to know, should I recommend this book? Okay, this is the book. Okay, should I put this book as label 1 given by the other book information? So let's see. If I want to put this on as label 1, then I need to check the properties of this one. What is the properties? This recommender is 1. Then I need to check what is the probability that the recommender 1, given that the label equals to 1. The label equals to 1 and the recommender is 1. Okay. The label is 1. The recommender equals to 1. The label is 1 and the recommender is 1. Okay. So among 3 labels that we have, there are 3 labels equals to 1. And among those 3 of those documents have the word recommender. So 3 out of 3, it is the probability. Now let's check. This is 1. 1 in the word intelligent. So I want to know what is the probability when the word intelligent equals to 1, given that the label equals to 1. Okay, we have the label 1, 1, and 1. So we have 3 documents with label 1. But how many of them where the word intelligent equals to 1? This is intelligent, 1. This is intelligent, 1. But this is 0. And it means 2 out of 3 of the document with the intelligent equals to 1, we can have the label equals to 1. So 2 out of 3 is this one. Now let's check next. The learning is 0, given that the label equals to 1. The label equals to 1, it is still 3, and the word learning is 0. The word learning is 0 is only 1. And 1 among those 3 documents, it is the probability. And the last one is school. School equals to 0. Then I want to know how many times that the word school, when the word school is 0, it has the label 1. So among those documents, word 0 school, word 0 school, and we have 2 out of 3 documents. It is the probability of the school equals to 0 given by the label equals to 1. So the probability that we have is approximately 0.149. Okay. So what should we give here? 1 or 0? We still do not have the value when the label equals to 0. So you need to calculate. Okay. I hope that you can understand this calculation. Can you calculate with the label equals to 0? Okay. If the probability here is 0.149 for label 1. If the label 0 is the probability is less than 0.149, then we calculate or we decide with the highest probability. Then the high probability is label 1. But if the label 0, if the label 0 is higher than 0.149, then we assign this one to label 0. Okay. So the highest probability will be assigned to this one. Okay, that's the way to use the probabilistic method. So the other way to do this one is using the term counts. The term counts means we learned about the counts in the TF-IDF. So it means how many times that the term appears in the document. So the simple approach, calculate the probability of term appearing in the document with a particular class. And in order to prevent zeros in the probabilities, we can use Laplace smoothing. So Laplace smoothing, or we call it at one smoothing. It means if there is 0, for example, if this one, we can make sure that there is no 0 because it is only Boolean 0, 1. Okay. But when we do with the term counts, there is a probability that the result might be 0. This is the formula. The probability of VI. VI means the frequency, the relative frequency. Sorry, VI is the words in the document. So we can have the conditional probability of a term VI. So term means the word appear in the document of class C shall be estimated by this one. So the probability of the word recommend, example, the probability of the word recommend appears in the label 1. Means I want to know how many times the word recommend appears divided by the all terms in the document C. So if we use the count, what happened? If this one 0. 0 divided by 100, and the result will be 0. Okay, so we do not want to have this one. That's why we will do with the Laplace or at-one smoothing. So the nominator values will be added by 1. So if it is 0, then if it is plus with 1, then it will always have a value, even though the value later will be very, very small. So it will be plus by 1 divided by the all terms document plus V. V means the number of different terms appearing in all documents, or we call it the vocabulary. Maybe let's look at the examples. Okay. So we have this document. In the document 1, we have the word recommender, intelligent, and recommender. So this is the label 1. And the document 2, we have recommender, recommender, and learning. And this is the label 1. The document 3, we have recommender and school. This is 1. And the document 4, we have teacher, homework, and recommender. And this is label 0. Now, we would like to know what will be the label of document 5. Recommender, 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 teacher, homework. Is it 1 or 0? So we need to calculate. First, we need to check the total length of the documents is classified as 1. Okay, there are 8. So how can we get 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 terms when the label is 1. The length of document 4 is classified as 0. Okay, and we have 1, 2, 3. Okay, so the length is 3. The size of the vocabulary is 6. Why 6? Because we want to find only the unique words. The unique words means recommender, intelligent, learning, school, teacher, and homework. Okay, so we have 1, 2, 3, 4, 5, 6. Now I need to calculate when the label is 1, given given by the label 1, what is the probability when the word is recommended? What is the probability when the word is homework? And what is the probability when the word is teacher? Given the label is 0, what is the probability where the word is recommender, where the word is homework, and where the word is teacher? So look at the label 1. Okay. When we have the label 1, there are 5 words of recommender. 1, 2, 3, 4, 5. So 5 plus 1. 1 is the formula for the Laplace one smoothing. Okay. Divided by 8. 8 is the total length of the document plus 6. 6 is the size of the vocabulary. So we have the value 6 divided by 40. Now, if you look at the word homework, what is the word homework? There is no word homework in the label 1. Then it is 0. 0 divided by any value, it will be always 0. Okay. So when we have 0, what happens? When you the probability will be the multiplication of all those values. So if we have 1, 0, anything multiplied with 0, it will be 0. So if all 0, 0, 0, then we cannot get the value. Okay, that's why we will do with the raw plus 1 smoothing. We will add by 1. So the value of homework, even though there is no word homework here, we still have the probability that is very, very small, 1 over 14. And the teacher label 1, also we have 0 plus 1 divided by 8 plus 6. So the value is 1 over 14. So this is also very, very low. Instead of putting 0, we put the very small value. The same with this one. The same with this one. In this case, the word recommender is 1. The word homework is 1. And the word teacher is 1. So we have value of this one. And if you can see this one, there are 3 length. So the length is 3 plus 6, the number of vocabulary. Okay. Now, let's look at the prior probabilities. The prior probability means in this document, we have 4 documents. Out of 4 documents, there are 3 documents which are label 1. And we have 1 document which is label 0. Okay. Then I want to know if I put this one as label 1. I want to know if it is label 1, given that the word recommender, teacher, and homework. What is it? The word recommender, there are 3 times. Okay, the word recommender, there are 3 times in the label 1. So 6 divided 14, or this one is 3 divided by 7. Okay, this is 3 divided by 7 for 3 times, because there are 3 words of recommender. Multiply by 1 divided 14, which is the homework, and 1 divided by 14, which is the word teacher. And we have 3 divided by 4. 3 divided by 4 is the probability, or the prior probabilities, that there are 3 documents out of 4 documents which is label 1. Okay, we have 1, 2, 3 documents among 4 documents which are in the label 1. So the label 1, so if I want to assign this to label 1, then the probability is 0.0003. What about if I want to assign this to label 0? If I want to assign this to label 0, then there is 1 document among 4. So there is 1 document among 4. And in this case, we have 3 recommender. 3 recommender means 2 over 9 for 3 times, multiplied by 2 over 9, which is the word teacher probability in the label 0, and 2 over 9, which is the word homework in the label 0. And we can get this probability 0.0001. So what is the good label? It is the higher probability than this one. And we can say that it is classify the unlabeled document as relevant for the user. So 1 is assigned. So we assign label 1 to the document 5. Okay. Okay, let me stop. Let's have a break. Okay, I will continue after the break.